Mankind has always looked to the stars. Since time immemorial, the universe has been a source of fascination and fundamental questions. What else is out there? How was all this created? Where do we come from? We are on a never-ending journey of scientific discovery to the edge of our universe and beyond. Gazing far into infinity and the dream of discovering the origins of mankind is as old as civilization itself. But was the emergence of humanity a pure coincidence? Or are there other worlds in which life exists? Welcome to Spacetime with Ulrich Walter, astronaut and scientist. He knows incredible things await us in outer space. Only a few decades ago, we believed our solar system was unique, but the Earth is no more than a grain of sand on a gigantic beach. Our solar system is only one of a myriad of others. More and more planets are meanwhile being discovered in the endlessness of the universe in ever-decreasing intervals.
Are we alone in the universe? This, for mankind, is probably one of the most classic questions, according to the scholar Albertus Magnus in the early Middle Ages. At that time, the existence of exoplanets could only be believed to be true or dismissed. But today we know, yes, they do exist, lots of them, and some of them even have the capacity to support extraterrestrial life.
This is the search for our cosmic twin. The search for a second Earth, and the search for the answer to one of humankind's greatest questions. Does extraterrestrial life exist? Finding life on another planet. This would be the most momentous discovery of all time.
If our solar system really were the complete exception in the universe, life would naturally be a complete exception too. But today, experimental observations have shown us that planets are quite obviously the rule in the universe. Wherever stars are formed, planets seem to have been formed as well. And that, of course, enormously increases the chances of life. And that's why I believe the probability that life exists is certainly very high. As a scientist, I am, of course, waiting for the proof.
Like all planets, our Earth was also formed from stardust, a ball of molten rock surrounded by a poisonous atmosphere. Cooling led to the formation of the Earth's crust. Condensating water vapor became the sea. But how life developed from this dead matter remains one of humanity's great mysteries.
Of course, you can ask, what does Earth-like mean? If you look at what we have here, what makes us what we are, what makes up the Earth, it's more than just temperature. We have an atmosphere, we have water, we have land. We have oxygen here too. We have wind and a moon and all that. So you have to wonder, what would another planet need to have for us to regard it as Earth-like?
Finding an Earth-like planet created to produce life. That's what makes the search so fascinating. In 2017, around the red dwarf star TRAPPIST-1, scientists discovered a whole range of potential candidates.
What we now have to do is to characterize them well enough to grade them. We know that stars are very different in size, and the same is true of exoplanets.
Extrasolar planets, exoplanets, are increasingly being found. But of genuine interest are those resembling the Earth.
This TRAPPIST star is not a hot star. It's only half as hot as the sun, which means what we see here as bright light from the sun is seen there as a red glow, like an oven of about 2,500 degrees. That, of course, means the planets are much closer, which enables them to be as warm as the Earth. But there is only a red glow, so you can ask, are they Earth-like? What does that mean? We don't just want to stand around in water, but might also like to put our feet on dry land. There needs to be oxygen there. Is that the case on TRAPPIST? We don't know yet.
An indication for extraterrestrial life would be evidence of oxygen in the atmosphere of one of these planets.
Oxygen is a very reactive gas, which is why you often don't find it as such. We know on Earth, at least, that only biological processes in our plants produce oxygen. And with carbon dioxide, it's also quite similar. We excrete carbon dioxide, and that's why a composition consisting of a lot of oxygen and traces of carbon dioxide would really be something like a fingerprint for biological life as we know it.
In terms of size, the planets around TRAPPIST are comparable to the Earth, and there could also be water in liquid form there too, a basic condition for life as we know it.
TRAPPIST-1 is a very special solar system, as you can immediately see from this image. We not only have 4 terrestrial planets like in our solar system, but a total of 7, and that's really unusual. However, only 3 of them are at a distance that would allow the occurrence of liquid water. These 3 here are the only ones on which life could develop at all. Nevertheless, that will, in all probability, not be the case. The reason is the star itself. It is also unusual in that it is a so-called ultra-cool dwarf. As the name implies, it's so cold that it only shines very weakly. However, all 7 lie very close to their star, 25 times closer than the Earth to the Sun, to be precise. But in the end, the problem with this star is that it produces eruptions of X-rays every few days, every few weeks, and hurls these X-rays toward the 3 planets, which very probably destroys any biological life that could otherwise develop.
But if there is any biological life, we may be able to find it.
It's also possible to search for biomarkers. These are special molecules created by life forms that we know, such as microbes, or by algae, seaweed, or other things in the ocean. Methane, for instance, methylene chloride, or even laughing gas. These are compounds produced by living organisms, which are then enriched in the atmosphere. So when we examine the atmosphere of the planets in question, we can determine their spectral attributes.
The first step is finding evidence for the chemical components of life, carbon dioxide and water. But what actually constitutes life? We can only search for life in the form we know from Earth.
Biological life doesn't mean there's someone out there waving to us. It can be plant life, single-cell organisms. You could almost say green slime. But it means it would be a life form which is of biological origin. Whether anything could develop or has developed from this life would have to be examined more closely.
Life as it also developed on Earth billions of years ago.
When we search for life beyond the Earth, we are looking for microbial life. That has to be clearly understood. The simple reason is that even on Earth, the overwhelming proportion of biomass, believe it or not, is made up of microbes. These tiniest of creatures make up the biggest proportion of the Earth's biomass.
The Earth, the blue planet. A perfect system for developing and maintaining life. And yet, the physicist Stephen Hawking has prophesied that in 100 years' time, humanity will need to find a new home.
In saying that, of course, Hawking is criticizing the way we treat our Earth. The first thing he says is that we use the Earth in such a way that it may be uninhabitable in 100 years. People, think about what you're doing. That is certainly correct. But when he says we need to find a new home, then I have to say it's not as simple as that. Astronomers know the distances in space, we know the technology that's required, and we're nowhere near ready. We can't simply emigrate to Mars tomorrow morning. And I'm not sure we'd think it's such a great place, or whether we think Mars could be green one day, or whether we'd have to live our lives in greenhouses. And then if Mars wasn't suitable for settlement, because we need to go further away, the nearest possibility would be Proxima Centauri.
Proxima Centauri is the star nearest to our Sun, 4.3 light-years away. In cosmic terms, a stone's throw. And orbiting around the star is a planet that could have spawned life, Proxima b.
The search for life in the universe is the major issue occupying science. Quite simply because no one can tell me they're not interested in it. That's the assumption. And should any absolutely irrefutable evidence for life in the universe be found, we'll see that in comparison to this. Every other scientific matter will take a back seat. In other words, this is the search for the holiest grail of all.
And the search has only just begun. Ever more planets are being discovered within and beyond our galaxy.
Incidentally, there are planets and there are planets. The differences are significant, and our planet system is perfectly suited to demonstrate this. Let's begin at the center. This is Mercury, then comes Venus, then Earth, and then Mars. And these four innermost planets have one basic property in common. They are solid. You can stand on them, and that's why they're called terrestrial planets. As we go further outward, this changes dramatically. Here we have Jupiter, Saturn, Uranus, and Neptune. They look roughly the same size, but the proportions are not quite right here. Jupiter is much larger than all the others. These four outer planets, however, are not rock planets, but gas planets, and are made up completely of gas. You can't stand on them. The size of these gas planets increases as we get closer to the Sun. The largest, Jupiter, is therefore closest to the Earth. We know that's no coincidence, as this occurs in all planetary systems. How do we know this? Well, today, we have telescopes which enable us to see that all planet systems are structured in roughly the same way.
It's not much more than 100 years since Albert Einstein's theory of relativity fundamentally changed our understanding of space, time, matter, and energy. It opened the door to modern cosmology and astrophysics. In only a few generations, knowledge of our planets and solar system increased enormously.
We humans know our place here in the solar system. We are the third inner planet. Mercury is hot, Venus is also hot, Mars is too cold, and so we realize how wonderful the Earth is. The other planets are also very nice, but they're not green. They have no water as such. No one can live there. The Earth is different from all the other planets because it happens to be in the area where water is liquid.
Our astronomical worldview has changed uniquely. When the astronomer Galileo Galilei turned his new invention to the sky over 400 years ago, new worlds were opened up. Galilei's telescope was the key that unlocked the doorway to the universe. He discovered the moons of Jupiter, as well as the phases of Venus. In his search for our origins, Galilei uncovered new worlds and new worldviews.
For us, it's generally all about understanding who we are. Science is often very egocentric. We want to understand who we are, how all this came about, how life is really created. Is it really such a one-off event? Does it happen more frequently? Is it just a matter of time?
It's this insatiable curiosity that drives mankind onwards. The advent of space travel finally launched the real exploration of our solar system and the quest for new knowledge about our origins.
It's only since we've had space probes and the ability to travel there that we've really been able to examine what's happening on the surfaces. We've sent probes to the moon, sent probes to Mars. We've sent them to Saturn, to the Saturn moons, to other bodies that happen to be flying by. And above all, we got excellent photos and huge amounts of data on magnetic fields, on compounds, etc. That means space travel has multiplied our knowledge, and every year we are adding new information to it.
Stepping into the space age extended our knowledge of our home planet Earth and its relationship to the entire cosmos. Probes launched by man into space explore the solar system and advance right to its very edge. From the outset, our neighbor Mars has always attracted very special interest. We meanwhile know that in its earliest times, the red planet had oceans and also a much denser atmosphere. But was Mars also perhaps home to primitive forms of life?
It's conceivable, and there are indications that there was liquid water there at some point. River valleys can be seen on its surface, and that's where we would certainly want to look for evidence of life. Whether we will actually find life there today can't be completely ruled out. Or maybe we'll find traces of earlier life in the rock.
Completely different from Mars is Jupiter, the largest planet in our solar system. This giant is 11 times the diameter of the Earth.
Decisive for the formation and development of any planetary system is the so-called gas giant. In our solar system, it's Jupiter, and we're going to take a look at it now. You can see it here in the background. It's simply enormous, almost like another small sun that really seems to radiate from within a little. A typical feature are these different alternating light and dark bands. They move in opposite directions, and this causes the formation of cyclones at the edges. These can sometimes be quite large, sometimes leading to the formation of huge, well, eyes, such as this red spot, the famous Great Red Spot that's been visible for hundreds of years.
The red spot is an anticyclonic storm with a diameter of 1,600 kilometers. Jupiter is a complex, gigantic, and turbulent world, full of different phenomena. Yet without Jupiter, humanity could not survive. Like a giant guardian, it holds its protective hand over our solar system.
Jupiter has an enormous proportion of the gravitational pull in our solar system. It has quite a large mass and consequently diverts all manner of bodies that could otherwise enter the solar system and possibly hit the Earth. So it prevents impacts occurring that could otherwise destroy civilization.
More than 60 moons orbit this giant planet. The fourth largest of them is Europa, and on this Jupiter satellite, life could have occurred.
We know it has an ice covering several kilometers, and underneath this there must be an ocean of liquid water, because you can see this ice layer floating, so to speak. You can see it moving, and that means there is liquid water, the main component of life. We also know that the Jupiter moon is heated up by so-called tidal friction, which results in energy. And this is what causes the water to be liquid. So then the probability that such a moon has a core of rock, which is bound to contain carbon, is not at all that small. Carbon, energy, water. We know what that led to on Earth.
The moons of the gas giants in our solar system are increasingly becoming the focus for astronomers. In 1997, space explorers sent the probe Cassini to Saturn, which it reached 7 years later. On the Saturn moon Enceladus, Cassini observed geysers blasting molecular hydrogen out into space. This ice-covered moon has an ocean containing all the chemical elements of life.
Life on Enceladus would, of course, be life forms living exclusively in water, something fish-like, though I'd have to say that fish would probably be too big. So in these oceans, we would initially be looking for single-cell life forms. Of course, no one can say if anything more could develop from these life forms. Life needs one important factor, and that's time. And what we know from the Earth is that single-cell life forms developed very quickly, but the leap from single-cell to multi-cell took a very long time. In fact, billions of years more.
In September 2017, the Cassini mission came to an end after 20 years. The probe's energy supply was exhausted, and the spacecraft was allowed to burn up in Saturn's upper atmosphere. Right to the end, Cassini continued to send data and images back to Earth. There will, of course, be further probes sent out into deep space, in search of knowledge and life. And more, Neptune is the 8th and outermost planet in our solar system. But there are scientists who believe there is at least one other planet orbiting the Sun.
Certain observations of our planets can't yet be explained completely. There might be something out there. If there's something quite far away and it isn't very large and massive, its influence on the inner planets will be relatively slight. That's why no one can say that there definitely is something there, but it can't be completely ruled out either. There could well be something out there that's very far away.
Is there a mysterious Planet X orbiting on the edge of our solar system?
We have this wonderful thing in the sky called the Milky Way. It looks fantastic, but the problem is it consists of thousands of objects. And that does mean something can be hidden amid this background. And that's where this so far undetected planet could be.
We ventured beyond our home planet to appease our curiosity. But extraterrestrial life is something we still haven't found.
This ultimately brings us back down to Earth, so to speak. If we look at the other planets and have to say, okay, they are so different, then the Earth really is something special.
We have found the basic elements for life all over the universe, but not yet in a combination or an environment in which life could safely develop.
What properties must the planet actually have to support higher life forms? Well, the best thing to do is look at the Earth, because it's perfectly suited to supporting such higher life. The most important thing is this planet must have the correct distance away from its star. If it's too far away, water freezes, and that's not good for life. If it's too close to the star, it will be too hot. Water evaporates. Not good for life either. That means the planet needs to be in a special zone, known as the habitable zone. But there's more. If the planet is too small, its core would no longer be molten, and the magnet inside it would no longer flow, so it would have no magnetic field. And if it has no magnetic field, the sun's rays would hit its surface unhindered and destroy all life. So it needs a minimum size. Also, only a planet that's large enough, like the Earth, can maintain an atmosphere. Mars, for instance, is too small to have either a magnetic field or an atmosphere. And now we come to a very important and decisive point. A really good planet needs a moon orbiting around it, because if it doesn't, its axis will not be stabilized. Over millions of years, the axis tilt would vary, and that is not good at all for the climate. It would be constantly changing, and that's not beneficial to higher life. So, as you can see, lots of different conditions have to come together, and the question is there another planet anywhere out there that fulfills all these conditions?
The search for life in the universe is also the search for extraterrestrial intelligence. We haven't found it, and we haven't been found. Billions of unknown galaxies, consisting of billions of stars and their planetary systems. And yet the universe remains silent, and it can't hear us.
All these radio signals, We've been doing this now for around 100 years or so, and that's only 100 light years, which shows that it's only a very small area if we take the Milky Way as a whole. So even if they received a signal, and we knew where that was, and how long that communication path was, whether it would actually be possible to communicate is highly questionable.
By human standards, the universe is frustratingly huge. The light we see from faraway stars and galaxies is millions and billions of years old. We can only see the universe's past, and it would be exactly the same for any extraterrestrial civilization that may be looking out for us.
Assuming you're 1,000 light years away, which is relatively close, we would receive a signal that was sent over 1,000 years ago. And if we wanted to reply that we'd received the signal, it would take another 1,000 years for it to arrive there. So any communication that took place would hardly be free-flowing.
Despite all the technical advances in space observation, factors like time and distance make our existence in the universe so solitary. And still, we continue discovering more and more planets on which life could be possible. The first proof for the existence of a planet outside our solar system came in 1995. 51 Bighazi b, a gas planet half the size of Jupiter. As technology advances, the number of planet discoveries increases. Meanwhile, they number among the thousands. Many of them indicate conditions that would make life possible. And perhaps in the near or distant future, humanity really will need somewhere to escape to, once it has succeeded in killing off its own planet. Just like in the science fiction epic Interstellar.
Eine gefrorene Wolke.
But if we do find such a planet, will it be a world we will want to live in?
What we can see here is the famous Drake equation. And this plaque on the wooden panel hangs in the institute where he worked and where he wrote this equation. At that time, in the early 1960s, Drake wondered whether he could estimate the number of civilizations existing at the time, and thought, yes, that must be possible. If n is the number of civilizations today, then that depends on how many stars there are in our Milky Way, multiplied by the probability of that star having a planet, multiplied by the probability of a planet being in the habitable zone, multiplied by the probability of this planet actually developing primitive life, multiplied by the probability of this primitive life developing into intelligent life, multiplied by the probability of this intelligent life developing into a civilization that can communicate. And now comes an important factor. It depends on how long such a civilization can survive. If it bombs out after only 100 years, then the number today will be very small. If it exists for any significant length of time, then the number will be high. Does this equation make sense? Well, in theory it does. But the crux of the matter is this factor, these three parts, because we haven't the slightest idea how big these factors are. And consequently, practically, it makes no sense at all.
The search for life in space is a game of probabilities. Perhaps the development and evolution of life as it occurred on Earth was nothing but an incredibly huge coincidence.
We have discovered that practically all stars have planets, that all stars have a number of planetary systems. But now all the other things need to be factored in. Is there a magnetic field, for example, to divert the solar wind? Is there something like Jupiter protecting us from meteorites? Is there a moon stabilizing the axis? Is there perhaps the right concentration of oxygen? Once all this has been factored in, you arrive at a relatively small number.
An ideal method for studying exoplanets is the use of detectors, such as the Sophia stratospheric telescope, which is installed on board a jumbo jet. Planets are cold. They don't radiate heat. Sophia detects distant infrared radiation from outer space, the cool space between the stars.
The one thing is looking for exoplanets and finding them. The other is characterizing them. How can the atmospheres be determined? How can the characteristic colors of these atmospheres be measured? That's difficult for us to do from the ground because of interference signals from our own atmosphere. It can't be done from the ground, so we've got to go higher. It can be done with the Sophia telescope, for example, the Sophia Observatory, or you have to go into space.
Infrared telescopes must be kept very cool, for which liquid helium is used, and telescopes stationed in space can only carry a very limited supply of coolant. Once this is exhausted, the mission is over. In contrast, Sophia can replenish its helium supply each time it lands.
If you put a telescope onto a plane, you've more or less made every mistake it's possible to make. You haven't planted concrete in the ground, you have no rock foundation. It's not all calm and still, there's no dome shielding it from the wind. You've simply got a telescope on shaky ground, up in the air, traveling at an extremely high speed of 800 kilometers an hour. It's drafty, unstable, it vibrates, and then you have to carry out your observations. There has to be a very good reason for doing something like that. And there is. This observatory looks for distant infrared radiation from space, for everything that's cold, such as planets, dust, or cold gases, whatever there is in the cold of space between the stars.
The Flying Observatory combines the benefits of Earth-based observatories with those of telescopes in space. 99% of the disruptive water vapor layer lies beneath Sophia. The observatory bridges the gap between Earth-bound observation and space. It cannot, however, completely replace space telescopes.
Space telescopes have the immense advantage of having no atmosphere to deal with. I'm outside, away from the Earth's surface. There's no atmosphere, and so I have considerably less interference in my images.
The launch of the Hubble Space Telescope in 1990 heralded a new golden age of astronomy. Never before had humankind been able to gaze so deeply into space. The telescope can see to the very edge of our universe. This telescopic eye in space delivers images of bizarre, fascinating, and bewildering beauty. Landscapes of light, stardust, and clouds of gas formed by cosmic winds and radiation. And it searches for distant planets.
How can you find out if a star has a planet? Well, today, we use the so-called transit method. Let's take a look at it now. When a planet passes in front of a star, as we can see here, it covers part of the star. You can't actually see such a transit with a space telescope because the resolution today isn't sufficient. But what we can see is the so-called light curve. So, the Hubble telescope is in space, and it's observing a star. It then sees the light that enters the aperture here, and at the moment the planet crosses, the light intensity fades. Once it moves away, the intensity increases again. That's the principle of transit. But there are two problems. We can see one of them here, because when the light fades, it isn't necessarily caused by a planet crossing. It could be caused by these star spots here. Every star has such spots, and they revolve with the star. meaning that the fluctuations in light intensity could be caused by these star spots. The second problem is that the planet, of course, has to pass directly in front of the star. But that is rather improbable, because we are more likely to be observing the orbit from above, and the planet will be orbiting around the star. So this here is more of a coincidence.
The Kepler Space Telescope was developed exclusively to hunt for undiscovered planets. It brought the final undeniable proof that the Earth was neither unique nor rare. The Planet Hunter observed an area with over 190,000 planets in the Cygnus constellation, and Kepler was quite specifically searching for small terrestrial planets, Earth-like planets.
Kepler follows the Earth, flies behind the Earth, so to speak, and constantly observes a particular field. And there it was able to find long-period planets, which means planets as far away from their host stars as the Earth is from the Sun.
The Kepler telescope was able to identify several thousand exoplanets. This included a few dozen in the habitable zone, where any potential water would be liquid, a basic condition for life. And these were all discovered although Kepler was only observing a very limited area. Somewhere out there, a second Earth is turning. That much seems certain.
In every planetary system, there seems to be at least one planet at the right distance. We can already look at atmospheres on large planets, and what can be found in these atmospheres seems very exciting. We'll soon be able to examine smaller planets and look at their atmospheres. And apparently in this universe, we never find anything that doesn't exist somewhere else.
Kepler has also tracked down another phenomenon: planets orbiting a binary star system. The existence of binary star systems has been known for some time, but the fact that there can be planets there too is a completely new discovery.
Normally, we only know planets which orbit a single star like the Sun, but there are also planets that orbit two stars. In the Star Wars film, there's that planet Tatooine, or whatever it's called. And there you can see two suns rising next to each other. For a long time, no one had even considered whether it would be possible for something like that to be stable. But now systems have actually been found where one planet orbits two stars.
Meanwhile, we know that planets in binary star systems occur just as frequently as in systems with only one star.
Generally speaking, there are two types of star systems: single star systems and double star systems. The ratio is about 50-50. When we stand on the surface of a planet in a single star system, for instance, and look at its star, it looks rather like this. That's just one half of all star systems. The other 50% have two suns. I'll just draw another smaller one. Typically, one sun is larger than the other, and these two suns revolve around their common center of mass. I'll show it like this. Now, if there's also a planet in this double star system, there are two possibilities. The planet could be close to the two suns, in which case, that's really bad luck, because the gravitational pull will divert it between the two stars. It will get closer to one of the suns and hurled far out into space somewhere. And that's that. There'll be no life there. Then there's a second possibility. The planet is further away, let's say here. In the center, it only sees one mass, the sum of both masses, and its movement takes it more or less stably around them, varying a little, but generally always around these two suns. That means it has a stable orbit, but the fluctuations mean that the climatic conditions on the planet are very erratic. In other words, primitive life could develop here, but not higher life forms, which need stable climatic conditions.
The Kepler Space Telescope can only detect planets. It can't examine them scientifically. This task is taken on by the James Webb Telescope. This giant space device is to investigate the already discovered small Earth-like planets much more closely and provide the scientists with entirely new insights.
Obviously, we want to get to the point where the atmospheres of terrestrial planets can also be analyzed. For this, the James Webb Telescope is the next step. It will have very good spectrographs, which may enable us to observe and follow transit planets, and the task then is to analyze the atmospheres.
The James Webb Telescope is a giant observatory floating in space, an all-round telescope which can peer much deeper into space than even the Hubble telescope. James Webb can carry out observations in both the infrared zone and invisible light, an enormous cosmic eye. Telescopes on Earth, in the stratosphere, and in space are the astronomers' sensory organs. But even though the closest extrasolar planet is, in cosmic terms, orbiting right on our own doorstep, for humanity itself, it's out of reach.
Assuming we don't only want to observe such a planet, but actually want to fly there, well, Alpha Centauri, the closest one, is 4.3 light years away. So if I wanted to fly there in my shuttle, it would take me thousands of years, much too long. Now, Breakthrough Starshot's idea is that we would have to travel at almost the speed of light to get there. So we take a tiny chip on a large sail, about 1 square meter, and bombard it with extremely powerful lasers. To provide this amount of energy, however, an entire nuclear power plant would be needed. And that would give me 20% of the speed of light, and would only take 20 years to get there.
The project is being financed by private individuals and supported by the physicist Stephen Hawking.
It's the first project I know of that could actually bridge this enormous distance. That's what makes the project so exciting, and therefore it makes sense to think about this further. But at the moment, I believe this project has to take a back seat behind the countless other interesting projects, because they have much greater probabilities of success.
Detecting Earth-like exoplanets close to our solar system is the principal goal of NASA's TESS mission. The intention is to compile a catalogue of exoplanets for more detailed investigation by Earth-bound telescopes. This satellite equipped with cameras is a small space telescope and will be focusing especially on stars the size of our Sun and searching for terrestrial planets.
Ultimately, we have to say that due to this research, we're seeing the planets in a completely new light. Because our division up to now into 2 categories, terrestrial and gas planets, isn't true for many other systems. There are planets which are so hot that it can rain something like sand. They don't have clouds of water vapor, but have silicon compounds that then rain down. Then there are planets that do have liquids on their surfaces. So there could well be something like water planets, which have some kind of mix like the Earth. There are so many different variations.
The Europeans have also launched their search for a second Earth. The European explorer Cheops is set to investigate known planet systems around neighboring suns. Its task is the more detailed exploration of Earth-like exoplanets. Is there an atmosphere? And what is it made up of? Is there water? And can the chemical components for life be found there?
In this universe, we can't find anything that doesn't exist somewhere else. There are planets whose densities you can calculate, and the result is the density of water. There seems to be planets covered by oceans, which is also very curious. Planets have been found with densities which are exactly the same as carbon. There could well be a huge diamond out there in the universe somewhere. It would be immeasurably valuable, but there's no way to get there. Somehow we now seem to know that there's nothing in this universe that doesn't exist somewhere.
The super eye of humanity is currently being created somewhere in the Chilean Atacama Desert. The EELT, the European Extremely Large Telescope, the largest telescope in the world. This gigantic eye for the sky will begin operating in 2024 and is the first telescope that can observe extrasolar planets directly. The EELT aims to scour their atmospheres for signs of life.
In 20 years, we could be capable of analyzing the atmospheres of terrestrial planets so precisely that we can say, I can see the signals here, and they can no longer really be explained by geological processes. The best explanation for them would be that there may be bacterial life there which has produced these substances.
It is out there somewhere, the planet with conditions suitable for human life. Perhaps with the answers to the question of our origin and the destination for future generations of space travelers.
The search for other planets is more than just the search for somewhere to relocate to. I think that even if we didn't have to move, or shouldn't move, or didn't want to, finding out if there were other planets supporting life would still be of interest. As with the questions, are we alone? And where do we come from? Ultimately, human beings have a need to know where they came from and where they're going. And the question about other planets is just a facet of this need.
Only a few hundred years ago, mankind believed itself to be the focus of all being. We have now long accepted the knowledge that we are no more than the briefest of moments in infinity.
We will certainly find life somewhere. In our solar system would be nice, of course, as we could study it in detail. But also with regard to life in outer space, the trend is moving towards the idea that we do live in a green universe, that life is possible, especially bacterial life. The question is, however, how probable is it that there's another intelligent civilization existing in parallel at the same time as us, which we will be able to make contact with?
Finding an extraterrestrial civilization is pure science fiction, but discovering the origins of life, the beginning of a biological evolution, the likelihood of this is increasing all the time.
I believe that life will actually be discovered outside the solar system first of all, by finding a curious composition within an atmosphere similar to what we have on Earth, and then saying this composition can only be the biological origins of life. And that's how I believe the discovery will be made. Inside the solar system, it will be difficult. We've been scrutinizing Mars for some time now, and it appears to be dead. And technologically, we are a relatively long way from missions to the Jupiter moons, or the Saturn moon Enceladus. Plans are being made, the intention is there, but it will take another 10 or 20 years to actually achieve it. Whether I'll see it happen, I don't know.
The search goes on. New insights into our universe are being discovered ever more quickly. Maybe this exploration of new worlds will solve the mysteries surrounding our own origin.
Are we alone in the universe? Let's first take a look at our Milky Way. It has around 100 billion stars and probably just as many planets. We know today that 1 in 1,000 planets could support life. That's about 100 million planets. But evolutionary biologists say that only on 1/billionth of them could life really develop. In other words, this probability only occurred on Earth. So in the Milky Way, we will probably be alone. But our universe is almost infinitely huge. And in an infinitely huge universe, there are an infinite number of planets. In other words, in our universe, we are certainly not alone.
Is the development of life on Earth really just the result of an accumulation of incredible coincidences? The search for planets outside our solar system and their investigation has opened up entirely new worlds to us. By gazing into the depths of space, we have come to realize how special our own solar system is. And one day, on a planet like our Earth, we will find life.